Okay, so today we are going to cover the first half of section 7, graphing polar graphs manually. You're going to need some graph paper, so if you haven't already, go grab some at the back, or if you printed out the notes, you should be fine. Later on, we'll be sketching graphs. You can use your calculator for those. Okay, so the first graph we're going to look at is manually sketching the graph r equals 3. So it doesn't matter what theta is. R is 3. We talked about this a little bit the other day. So if theta was 0, r would still be 3. Theta was 5 pi 12ths, r would still be 3. 3 pi 4ths, r is still 3, and so forth. And you can test this for all the points. It doesn't matter what theta is, r is still 3. So what we're creating is a circle, beautifully drawn of course, of radius 3. Our other option for just basic graphs is when theta is set. So here, theta equals 5 pi 6. It doesn't matter what r is, theta is 5 pi 6. So r could be positive 1. Theta is 5 pi 6. R could be positive 3. Theta is still 5 pi 6. It could be 4. It could be 2. It could also be negative 1. It could be negative 2. It could be negative 3. So what we're creating here is actually a straight line going through 5 pi 6 and 11 pi 6. So those are our two most basic graphs that you don't really have to create a t-chart or anything for. What we're going to move on to now is graphs where it requires a little bit more work. So starting off here, r equals 4 cosine theta. In order to do this, you are going to need to make a t-chart where you have theta and you have r. So let's start with the typical ones we're used to. 0, pi 6, pi 4ths, pi 3rds, pi halves. We'll start there. If I plug in 0, cosine of 0 is 1. So this is 4 times 1. And yes, you are going to need to probably pull out a unit circle for this lesson. So you may want to pause the video now and get out your unit circle. Cosine of pi 6 is radical 3 over 2. 4 times radical 3 over 2 is 2 radical 3. Approximately, that's about 3.5. Pi 4ths. Well, cosine of pi 4ths is radical 2 over 2. So that is 2 radical 2, which is approximately 2.8. Pi 3rds. Cosine of pi 3rds is 1/2. 4 times 1/2 is 2. And pi halves, cosine of pi halves is 0. So that's 4 times 0, which equals 0. So if I were to plot just this first kind of quadrant here, we have 0, 4, or 4, 0 rather. 3.5 pi 6. 2.8 at pi 4ths. 2 for pi 3rds. And pi halves for 0. The problem is this isn't enough points to accurately show us everything we need to see. So we need to kind of plug in some more points here. If I were to keep going and plug in 2 pi 3rds and 3 pi 4ths and 5 pi 6 and then pi. Let's just go from 0 to pi. So if I plug in 2 pi 3rds, cosine of 2 pi 3rds is actually negative 1/2, which gives me a negative 2 here. Cosine of 3 pi 4ths is negative radical 2 over 2, which is going to give me a negative 2 radical 2, which gives me about negative 2.8. 5 pi 6, 5 pi 6 is 4, well, cosine of 5 pi 6 is negative radical 3 over 2, which gives me a negative 2 radical 3, which is approximately negative 3.5. And pi, cosine of pi is negative 1, so that gives me a negative 4. So plotting these points, I'm going crazy here, starting at 2 pi 3rds. So this right here is actually 2 pi 3rds, but I'm going in the negative 2 units, so that's actually going to be equivalent to 5 pi 3rds 2. 3 pi fourths and negative 2.8. So 3 pi fourths, even though it's over here, I'm going to go negative 2.8 units. And that's going to put me here. Oops. That's 3.8. 2.8 is putting me here. 5 pi 6 is going to be a negative 3.5, which is going to put me here, which is actually 3.5, and 11 pi 6. And then pi puts me at negative 4, which actually puts me at this first starting point again. So what we have created here, connecting the dots, is almost like a circular shape, like an egg-like shape. And if we notice what's important about this, and the really, really important thing about cosine, it is symmetric over the x-axis. If I were to fold this graph along this red line I just drew, it would be symmetric over the x-axis, or the horizontal axis. So cosine has symmetry over the horizontal axis. That is really important. Alright, so that's our first one we're going to look at. Now we have 4 times 1 plus sine of theta, and I know my graph here is in terms of degrees, but we're going to stick to cosine, or to radians, and the problem was I just needed a bigger graph, and this was all I had. Alright. So, what we have here is 4 times 1 plus sine of theta. That is equivalent to 4 plus 4 sine of theta. Make it a little easier to do the calculations. So we have theta, we're going to have 4 plus 4 sine of theta. So same thing, we're going to start with 0, pi 6, pi fourths, pi thirds, and pi halves. We'll start there. If I plug in 0, this is 4 plus 4 times sine of 0. Sine of 0 being 0, this becomes just 4. Pi 6. Sine of pi 6 is 1/2. So that becomes 4 plus 2, which is 6. Sine of pi fourths is radical 2 over 2. So that becomes 4 plus 2 radical 2. 2 radical 2 we approximated to be about 2.8, so 4 plus 2.8 is 6.8. Pi thirds is 4 plus sine of pi thirds is radical 3 over 2. So this becomes 4 plus 2 radical 3. We approximated 2 radical 3 to be about 3.5, so 4 plus 3.5 is about 7.5. And plugging in pi halves, sine of pi halves is 1, so we end up with 8 here. So if I graph this, I have 4, 0, 6, pi 6, 6.8 pi fourths, 7.5 pi thirds, and 8. I'm actually going to plug in a little bit different values here. I'm not going to go jump down to quadrant 3. Oops. So if I plug in quadrant 3 here, 7 pi 6, 5 pi fourths, 4 pi thirds, and 3 pi halves. Plugging in 7 pi 6, sine of 7 pi 6. Sine of 7 pi 6 is negative 1/2. So this really becomes 4 minus 2, which is 2. 5 pi fourths, that's 4 times negative radical 2 over 2. That gives me a 1.2. 4 pi thirds, sine of 4 pi thirds is negative radical 3 over 2. Which is going to give me a 0.5, because 4 minus 3.5 is going to give me 0.5. And then finally, 3 pi halves. Sine of 3 pi halves is negative 1, and I end up with 0 here. So plotting, this was where we ended last time. Plotting these new 4 points we just graphed, we have 7 pi 6. 7 pi 6, which is actually down here, 2, seven pi 6, 2, puts me right here. 5 pi 4ths, 1.2, puts me like right there. 4 pi thirds, 0.5, puts me right there. And 3 pi halves, 0, puts me right here. And this may look kind of crazy, but the thing about sine is that we know, well, we don't know yet, but you're going to know a special case. Cosine was symmetric about the x-axis. Sine will have symmetry over the vertical axis. So what that means is I can actually take this and imagine if I folded it right over this horizontal axis here. I could create and fill in the rest of this just using symmetry. So just using the symmetry here, I know that this point is going to match up to this point right here, and right here. So just filling those in, those blue dots there, are symmetric to these red dots here. Since I know I have 0, 4, I know I'm going to have pi 4. This at 150 degrees here is going to be equal to this point right here, which is at 6. And then we're going to be at 6.8 here, 7.5 here. And we create a shape using symmetry here that if I were to fold over that blue dotted line should be the exact same. And that's really how we're going to solve all of these. If it's cosine, we know it's symmetric over the horizontal axis. If it's sine, we know it's going to be symmetric over the vertical axis. And that is really, really, really important. Alright, so here we have 4 sine of 3. Just recognizing that as sine, we know it's going to be symmetric over the vertical axis. Alright, so setting up our t-chart here. So we have 0, pi 6, pi 4ths, pi thirds, pi halves. Alright, we'll start there. Now this is a little different because this is 4 sine of 3 theta. So this is really going to be 4 sine of 3 times 0, which is 0. Sine of 0 is 0, so that's really just 0. Pi 6 is going to be 4 sine of 3 pi 6. 3 pi 6 is equivalent to pi halves. Sine of pi halves is 1, so this is 4 times 1. We get 4. This becomes 4 sine of 3 pi 4ths, which is going to be 4 times radical 2 over 2, which gives me 2 radical 2, which we've approximated today to be 2.8. This is 4 sine of 3 pi halves, or 3 times pi thirds, rather. 3 times pi thirds is really just pi. Sine of pi being 0. This is 0. 4 times 0. At pi halves, this becomes 4 sine 3 times pi halves is 3 pi halves. Sine of 3 pi halves is negative 1, so 4 times that becomes negative 4. And if you notice, even though we've only gone from 0 to pi halves, in this column we've gone from 0 to 3 pi halves already. What this 3 here does, it affects our period, just like when we were graphing sine and cosine curves and all of that, and x distortion affects our period. So it's going to affect how often our pattern is repeating here. So we don't actually have to plug in as many points for this one because it'll start repeating faster. For instance, if we go ahead and plug in the next value, which would be 2 pi thirds, that becomes 4 sine. Well, 2 pi thirds times 3 is 2 pi. We've already gone one full revolution from 0 to 2 pi. Sine of 2 pi is 0, so once again we're back at 0. So if we were to go ahead and begin graphing this, let's choose a different color. We have 0, 0. We have 4 pi 6. We have pi fourths, 2.8. And then we're back at pi thirds, 0. There's 0 pi thirds. Then we're at negative 4 pi halves. So pi halves is up here, but negative 4 is actually going to drop us down here. And at 2 pi thirds, we're back at 0. What is happening here is we're going to start off here, and everything you draw needs to be curves. There's no straight jagged edges or anything with this. It's all nice smooth curves. We're going to curve up here, and then we're going to hit this point, we're going to come back down here. And from that point we actually come down here. And we know, since we have this right here, it's symmetric over the vertical axis. We know that. So imagine folding it over this line right here. What do we know has to be true then? Well, then we know this needs to keep going back up here. We know that this pi 6, or 4 pi 6, is going to coordinate to a 4 5 pi 6 over here. And this 2.8 pi fourths is going to coordinate to a 2.83 pi fourths. So we can go ahead and fill these in and make it symmetric. So once you kind of get used to doing these, you're going to be able to recognize the symmetry anymore, and you're going to be able to fill the graph in completely with less points. Also, the further we get into this, we're going to be able to tell you right away, you know, how many petals it should have and all of that, just from the information for sine of 3 theta. But for today, we're just plotting some points, experimenting with our graphs. So here we have 5 cosine of 2 theta. Cosine of 2 theta tells us we need to be symmetry over the horizontal. Symmetry over the horizontal. So we set up our t-chart here. It's going to be 5 cosine of 2 theta. Alright, so starting 0, pi 6, pi fourths, pi thirds, pi halves. We'll at least go to pi. 2 pi thirds, 3 pi fourths, and 5 pi 6, and then pi. Let's see where that gets us. Alright, so if we're plugging in 5 cosine of 2 theta, this is going to be 5 cosine of 0. Cosine of 0 is 1, so that's 5 times 1. We get 5. Pi 6 times 2. This is going to be 5 cosine of 2 pi 6. 2 pi 6 is equivalent to pi thirds. Cosine of pi thirds is 1/2, so this is 5 times 1/2. 2.5. Cosine of 2 times pi fourths is 2 pi fourths, or rather just pi halves. Cosine of pi halves is 0, so this is 5 times 0. We get 0. Pi thirds times 2 becomes 5 cosine of 2 pi thirds. 2 pi thirds is negative 1/2, so we get negative 2.5. If I plug in pi halves, this becomes 5 cosine of pi halves times 2 is pi. Cosine of pi is negative 1, so that's 5 times negative 1, negative 5. If I times 2 pi thirds times 2, I get 4 pi thirds. Cosine of 4 pi thirds. Cosine of 4 pi thirds is negative 1/2, so I end up getting negative 2.5 again. 3 pi fourths times 2 is 3 pi halves. So we're actually plotting more points than we even need to here, but that's alright. 3 pi halves is, cosine of 3 pi halves rather is 0, so this becomes 0. 5 pi 6 times 2 becomes 5 cosine of 5 pi thirds. Cosine of 5 pi thirds is 1/2, so it's 5 times 1/2, positive 2.5. And then finally pi, this becomes 5 cosine of 2 pi. Cosine of 2 pi is 1, so we get 5 here. So plotting these, we have 5, 0, 2.5 pi 6, 0 pi thirds, negative 2.5, 0 pi fourths, negative 2.5 pi thirds. So at pi thirds, or 60 degrees, we're at negative 2.5. So that's actually going to put us down here. At pi halves, or 90 degrees, we're at negative 5. So that puts us down here. At 2 pi thirds, right here, we're at negative 2.5. So that puts me here. At 3 pi fourths, I'm back at 0 again. At 5 pi 6, I'm at 2.5. So I'm actually over here now. And at pi, I'm at 5. Now remembering I am symmetric over the horizontal here, I can go ahead and match these points up. I can also start, if I started from the beginning, you kind of see the pattern that's going on here. It's going to move up like this, and then move like this. But I need to imagine folding over this black line and making it symmetric. So if I make it symmetric, we're going to have a point matching up here and a point matching up here. This one's going to match up here. This is going to go here, and this is going to go here. And it's going to continue just like this. Creates a nice little shape there. Once again, the key, really important thing here is recognizing the symmetry. It's what's going to help you save time instead of plugging in all the points. Alright, we're going to do one more by hand. I'm not going to do the last two with you guys. So if we look at these, here I have 1 minus 3 cosine of theta. Once again, cosine, I need to think horizontal symmetry. Right, need to remember horizontal symmetry. Setting up our t-chart. Typically 0 to pi should cover most of the time. Alright, so this is going to be 1 minus 3 cosine of 0. Cosine of 0 being 1, so this is 1 minus 3, or negative 2. This is going to be 1 minus 3 of cosine of pi 6. Cosine of pi 6 being radical 3 over 2, which equals negative 1.6 when you actually plug it in. If I plug in pi 4s, this is 1 minus 3 times radical 2 over 2. And I can't remember, I think it's negative 1.1 approximately. And these are all rounded approximations. If I plug in pi thirds, I'm going to be at 1 minus 3 times 1/2. Cosine of pi thirds is 1/2. 1 minus 1.5 is negative 0.5. And if I plug in pi halves, that's 1 minus 3. Cosine of pi halves is 0, So I end up with positive 1. 2/3, that's 1, or 2 pi thirds. Cosine of 2 pi thirds. Cosine of 2 pi thirds is negative 1/2. So this is actually going to be 1 minus a negative 1.5. Becomes 1 plus 1.5, and I get 2.5. If I plug in here, okay, so plugging in here, we have 1 minus 3 times negative radical 2 over 2, which I believe, I can't remember off the top of my head, is somewhere close to 2. Somewhere close to 2. We'll show it on the symmetry here. If I plug in 5 pi 6, cosine of 5 pi 6 is negative radical 3 over 2. And I believe this equals 3.6. Finally plugging in pi. Cosine of pi is negative 1. So this becomes 1 minus a negative 3, which is 4. So if I plot these, I have negative 2, 0, which is actually going to put me over here. When I have pi 6, I'm at negative 1.6. And theta is pi 4, so I'm at negative 1.1. When theta is pi thirds, I'm at negative 0.5. Oops. Careful when you're drawing your lines, it's really easy to do what I just did and get on the wrong line. So at pi 6, which would be 7 pi 6, I'm at 1.6. And then I'm at 1.1, and then I'm at 0.5. There we go. When I have pi halves, I'm at 1. So it's going to put me up here. When I'm at 2 pi thirds, I'm at 2.5. So put me up here. When I'm at 3 pi fourths, kind of 3 pi fourths should be a bit greater than 2. That calculating is wrong, and I don't have a calculator with me, so I can't do that. So whatever that equals, sorry guys, you'll figure that one out with a calculator. If I plug in 5 pi 6, I'm at 3.6, which puts me here. And if I plug in pi, I'm at 4. So now what I can do is I can go ahead and use the fact that it's horizontal over the symmetric line, or horizontal over the symmetric over the horizontal, sorry, can't talk today. So it's going to be symmetric over this, so I can find my matching points here. Draw my symmetry in. Here. And what we actually have is, ooh, this should look something like this. What I would like for you guys to do for the rest of the class here now is to get out your calculators. We're not going to do these last two by hand. First of all, make sure your calculator mode is in radians. Make sure it's in polar mode. And that your theta minimum is 0, your theta max is 4 pi, and your theta step is pi over 48. So let me pause this real quick. Okay, so I went ahead and pulled up mine. So I want my theta min here that I have blinking to be 0. My theta max, I can go ahead and enter 4 pi. And I want my theta step to be pi divided by 48. Now, like your x minimum and your x maximum, you can change those and adjust those according to your graphs. I want you to take about the next 10 minutes or so, work through the next couple problems that are in your notes, and I want you to just experiment. Experiment, for instance, with this first one. The first one you are graphing is, let's see here, cosine of 4 theta. So if I were to plug in cosine of 4 theta, and take a look at the graph. Now, that's a little small, so obviously I need to adjust my window. So I'm going to make my window, leave your thetas alone, make your x-min, let's go -2 to 2 for both x and y's. Now if we take a look at a graph, we get this cool little like flower shape. And what I want you guys to do is experiment. Like what happens if I change cosine of 4 theta to cosine of 8 theta? If you notice here, I actually have more petals. What if I change it to something like odd, so cosine of 5 theta? A little less. And so I want you guys to experiment with this. Take the next couple of minutes, work through some of these problems, and draw some sketches of it. You will have to adjust your window for some of these. The only one I want to give you a special hint for, that's next class, is this r squared equals 16 sine of theta. In order to enter this, you need to solve for r. So if I solve for r, I get plus or minus the square root of 16 sine of theta. Problem is, it's hard to enter plus or minus. So what you're going to do is in your first option, r sub 1 is going to be the positive, then our r sub 2 to make the negative. And that is how you'll make sure of this. So take a few minutes, draw some sketches, work through some of these, change it around on your calculator, experiment with window, all of that. And when you're done, you can work on homework for the rest of your class. If you have any questions, just let me know. And if not, I hope you guys have a nice weekend, and I will see you guys either tomorrow or Monday. Thanks.